So guys, today we learn about asymptotic notation. And what is asymptotic notation? There are three most important feature in it. First one is big O, the second one is big omega, and the third one is big theta. So what is big O? Big O is upper bound. Upper bound means it required the maximum time. Mean to say a program required maximum time to run. So it is mostly known as worst case time complexity. So we will learn it in detail by a graph. But first of all, we learn the main definitions about it. And the second one is big omega. It is also known as lower bound or best case time complexity. So in which a program required minimum this time to run. Mean to say at least it required this time to run. So you can say that it is rarely a case. Mostly we will deal with big O. So the third one is the third one is theta. It is also known as tight bound, in which we have to deal both the upper bound and lower bound. So you can say that it is average case time scenario. So it is mostly most accurate and most rare one to use. So the most important one is big O. So we will start with big O. So how big O works? So it is very simple. As I mentioned, I will teach you with the help of a graph. So in big O, first of all we will mention it is a big O. Now we have to write it down. So first we need a graph. Okay, so here is the first line and the second one should be something like that. It is our time, it is number of times, it is our first function which is known as fn, and the second one is known as gn. Okay guys, and here is also a c constant, and here is also a k constant. It mean to say before this is a fluctuation and the real result will be this. So that's why we use big O, a bigger value that at most. Mean to say we have to choose a bigger value to test big O. So how can we test it? It is very simple. First of all, the derivation, mean to say the equation we mostly use in big O, it is fn is less than constant gn. And what is this? So we will write it down with mathematical approach, so we will better have an understanding of it. 2 and 2 plus n is our fn, and our constant would be something like 3 or 4. I would prefer 3. And our gn, which is a dot mean multiply, and gn would be, I think so, I will prefer the most bigger value is n2. Mean to say that we always have to choose at most, mean to say the bigger one. If there is n3, I will choose n3. Okay, in big O situation. So we will write down, if n is equal to, I would say that equal to 5, then what would happen? 2 5 2 plus 5 is less than 3 5 raised power 2, and the answer should be 55, and it is something like 75. Okay, hope you understand it. So just remember that big O is the most used time complexity in the algorithm. So all the question which is based on exam or interview is mostly related to big O. Okay guys, so now we jump to big omega, and let's see what can big omega do for us. In big omega, first we mention it big omega, and the sign would be something like that, and the graph should be little bit different, but approach would remain the same. And the function here, the fn took at least minimum this time, and cgn is here. As usual, you know the constant for fluctuation control, n and t. So how can we write it down? It is simple. It is the best case scenario, and it is also known as lower bound, and we should say that at least. Just remember this word, okay? So how can we use it? It is very simple to use. In this, the function of fn is greater than equal to gn or omega. You can write it down like that, or you can also write it down like that. So it is very simple to write. So as we know, we have to take some values. So I will prefer the simplest one. This is a 2n raised power 2 plus n is greater than cn. So here we choose at least, as I mentioned, at least. So at least you have to choose 2 or 1, not 3. Okay, 2 and 2. So if we put n is equal to 2, it would be 2 to the 4 and 4 to the 8. 8 plus 2 is 10. Okay, and here 8 and 8 is less than obviously 10. So here is our case for big omega. And now we proceed with the last one, is known as theta. And the last one is theta. And how can we use theta? First of all, I write it down theta for you. The symbol is this. Now we have to draw a graph. In theta we have to draw at least 3 graphs. So it's mean to say it is something like that. It is our fn, and it is just like that. It is our c2 dot gn, and it would be c1 mean to say constant one dot mean multiply and gn. Okay, as usual, n, t, and here is our constant. So all thing remain same, just a little bit of difference, just like that. c2 g n, sorry for that, gn is less than fn, it is less than c1 gn. So if you want to put something just like 2 and 2, 2 and 2 plus n, and this one is 3 and 2. So if we put n is equal to 2, 3, 4, it's on you. I am just use smaller value to calculate it better. 2 plus 2, and this one should be 2 raised power 2. So it would be 2 to the 4, 4 to the 8 is less than 10 is less than 2 to the 4, 4 3 the 12. So here is the case about theta, and it is so simple. So we can as you know, this graph, the most scenario like this and this one, and we try to approach this one. Okay, so mostly the problem lies in these two areas. Okay, and the most important for exam point of view and interview point of view is properties of asymptotic notation. So I will focus on 3 properties. First one is reflexive, symmetric, and transitive. So how can we write it down? As I mentioned earlier, I will write big O, big omega, I will prefer sign, and big theta. Okay, and small o and small omega. These are the sign we use mostly, small, but these 3 are the most important ones. So focus on these 3, please. So we mostly write it like that. fn is less than c dot gn. So what would if I write fn is equal to a and it is considered b? So it is easy to understand. Okay, so we can also write it like that. Okay, now we have 3 properties. For I can write it down like r for reflexive purpose, S for symmetric, and T for transitive. Okay, so in big O scenario, okay, I write it other scenarios, but I will write it down in this form, so would be shorter and easier to understand. And the third one would be, as you know, C1 Gn is greater than Fn is greater than C2 Gn. Okay guys, oh, last two. A is equal to B and A is less than or A is greater than B. So it's on you. So first of all, A is greater than B, A is less than B. Okay, it is a different. Big O have a equal to sign, it does not have a equal to sign, and big omega has a equal to sign, it does not have a equal to sign, it is a greater than sign, it is a less than sign, so it's okay to understand. Okay, what is big O? What is reflexive property? Reflexive mean it have to be equal by each side, mean to say that if I put 1 here, it should also be a 1 here, so it is possible. So big O is reflexive, yes, big omega is also reflexive, and big theta is also. So these three have the reflexive properties, but these two does not have it because it does not contain a equal to sign. Okay, easy to understand and for exam point of view. And what is symmetric properties? Symmetric property explained that is A is greater than B, it should also B is greater than A. So that is not possible. Mean to say symmetric say A is greater than B, then B is also greater than A. So it is impossible to achieve in these two. So not in these two. But the third one, it is possible, but in those not possible. Why? Because A is greater than B, yeah, B is greater than A. It's possible. Okay, you can consider it is B, B, A. Okay, this scenario it is possible. And what is transitive? Transitive means you have to, transitive means A is less than B, B is less than C. So if A is less than C is possible, yes, it is possible. And which cases? 1, 2 and 3 cases, but not in these. Okay, how is it possible in this case? It's in this case A is greater than B, B is greater than C, A is greater than C. So these are the properties of asymptotic notation, and it is mostly used in interviews and exam purposes, but in real life scenarios big O is the most used important thing, and you have to consider big O is the most important time complexity. Hope you like it.